YouTube doesn't seem to have updated quite yet. Let me check Twitch. Yeah, Twitch seems to be live. Good. Now YouTube is live as well. Okay. Welcome back, everyone. We just had a look at day 19. Oh, wait. Why didn't I get a star for that? It provides 1 gold star. But it doesn't show a gold star. Oh. There we go. Just had to hard refresh the page. Yeah, so as you can see, we tried day 19. Didn't quite get there. I'm not quite sure why, but we might look into that later. Anyways, we're gonna have a look at day 20, charting ahead. I've created a new folder here, nothing in it. Haven't looked at this yet. So let's go. Jurassic Jigsaw. The high-speed train leaves the forest and quickly carries you south. You can even see a desert in the distance. Since you have some spare time, you might as well see if there was anything interesting in the image the Mythical Information Bureau satellite captured. So we're breaking a bit with the story here because we didn't actually capture the image. We haven't gotten that far yet. After decoding the satellite messages, you discover that the data actually contains many small images created by the satellite's camera array. The camera array consists of many cameras. Rather than produce a single square image, they produce many smaller square image tiles that need to be reassembled back into a single image. Each camera in the camera array returns a single monochrome image tile with a random unique ID number. The tiles, which is my puzzle input, arrived in a random order. Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped to a random orientation. Your first task is to reassemble the original image by orienting the tiles so they fit together. Oh. I can see why this is tricky. To show how the tiles should be reassembled, each tile's image data includes a border that should line up exactly with its adjacent tiles. All tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. For example, suppose you have the following 9 tiles. So this tile, and this tile, and this, and this. Well, 9? Yeah, okay, I guess that was 9. By rotating, flipping, and rearranging them, you can find a square arrangement that causes all adjacent borders to line up. So as you can see, all of these sort of are the same. All of these are the same. All of these are the same. All of these, and so on and so forth. For reference, the IDs of the above image tiles are these numbers right here. To check that you reassembled the image correctly, multiply the IDs of the 4 corner tiles together. If you do this with the assembled tiles from the example above, you get this number. Assemble the tiles into an image. What do you get if you multiply together the IDs of the 4 corner tiles? So this is my puzzle input, which of course is significantly more than 9 tiles. We're going to store that into input.txt. This is a tricky one. It also has flipping. That's a lot of possibilities. $1,728 lines. Wait, what? Each camera, single monochrome. Oh wait, that's not my number of tiles. Because tiles take more than one line. So tiles take about 12 lines. Yeah. So our image is 12 by 12. It's 12 by 12, and they can all be flipped and... Oh my. They can all be flipped, I guess, in both directions. And rotated. In a 12 by 12 grid. What in the... So we have... Jesus Christ, what is this task? We have 144 tiles. They can each be in 4 orientations. So they each have 4 unique orientations. And I guess they can be flipped like this way, that way, or that way. So that's 1, 2, 3. So we basically have 1,728 tiles in a 12 by 12 pattern. What? What kind of madness is this? I guess we could try, like, start with a tile in the upper left, see if we find a tile that can go next to it. If not, then try the flips, try the rotations. Oh crap, the rotations and the flips. And then go on to the next one. And for each of the ones we try, we also need to try all the rotations and flips. Oh, good lord. Okay. Isn't this... I think this might be way too slow. Probably gonna need these. So how do we want to store this? I think we might want to store this in a table. With our pieces is a table from just the number, the tile ID, to How big is a tile? 320. So a tile is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so they are 10 by 10. So a tile is a 10 by 10 grid. So let data be the input from our file. And for tile in data dot splits on double new lines, dot split lines. This should give me all of the headings. Yep. And the empty one at the end. So let's title line be, actually let's lines be, sure, you can reuse this name. Let lines be tile.split lines, and grab the 0th line there. Sorry if I sound a bit defeated. I just think this is going to be super hard. If title line dot length is not equal to 0, then we say that title is equal to 0, 1, 2, 3, 4, 5. Title line 5 all the way up to the second most last characters. Parse this an integer. Just echo out that title. This should just be giving me a list of numbers now. Good. And now we need to parse these lines. Actually echo out for me lines.length. This should give me 11, I think. Yeah. So for line in lines 1 to the end, this should just be that. Line, so pieces from in title, I, so I'm just gonna do I, is equal to line map it, it's equal to this thing that returns a sequence, I guess. Got like that. Yeah, sequence of bool, but expected an array of bools. Can I do this? Just convert it? No. Oh, wait, like so. and y is equal to value. Right. Now we should have all of our pieces. Let's try to get piece number 3041. 3041. Just echo that one out. No. Pieces. Key not found. Why is that? Oh, the error was actually from in here. I should add my piece first. Pieces title is just let's create a type here called piece, which is just this double array, and have a piece there, because then I can say default piece. Oops. Pieces is the default piece. There we go. Okay, and does that match what we have here? True, false, false, true, true, false, true, false, false, false. That seems like this line here, which is great. It's kind of what we want. Right. Now, the shit show begins. Jesus Christ. So we have all of our pieces. So we need to store rotation and flip for our pieces. We really only need to be able to check the left and top border of a thing with what I'm planning to do. So basically my idea is, I just need, yeah. Basically my idea is like place this tile, just start with a tile, place it, then go to the next tile, check this edge against this edge. If it matches, insert it, go on to the next one. If it doesn't match, try all of the combinations it can have. If it doesn't match, then and we have tried all the pieces and none of them can match in any orientation, go back, change this one out, carry on. I guess we could also add some memoization to this to speed things up, because some pieces will never match. We'll look into that if it's slow. It's probably gonna be slow. Spoiler alert. But basically what we only need to be able to check. So for a given piece, we only need to be able to check this piece against this edge. And when we come down here, we need to be able to check, so like this edge against this edge. And we have this edge against this edge, checking from up here. So we only need to be able to check this edge and this edge. We actually don't give a shit about the data in the middle. But that is basically a couple loops for us. So I think I'm gonna write a match piece. A, B, which are integers, which maps into our table. You know what? Let's do the nice thing here that we did before. Oops. Let's also create a rotation, which is an enum, which is rotate one. Yeah. Don't need that. Rotation is an int, and flip flip x and flip y are booleans. And this returns a boolean. So I'm going to say match piece left. So A is going to be the piece that is already placed. B is the piece that we want to check against. So for x in 0 to 9, we're matching a piece to the left, so we only match a line. So pieces, let's grab these pieces out at the beginning, speed it up a bit. A piece is pieces A, B piece is pieces B. Oops. I have an idea if this is slow, which is probably gonna be. Yeah, so for that we need to check a piece. So this basically equal to B piece y and 0. If these are not the same, return false. Otherwise, return true. Oh, not otherwise, but if a loop hasn't returned false yet, return true. So at the moment, this doesn't do any rotation, any flipping, any stuff like that. Do we have... Let's check if we have one of these, just for fun. So for piece in pieces.keys, and for just for A and B, I think. If match piece left, A, B, with 0 rotation and no flipping, not that it matters because we haven't implemented that. Echo A matches B. Match piece left. Oops. Right. So according to this, these pieces match 3011 to 3911. So look at 3011. 30, 11. There. Let's have a look at what was the other one? 30, 11, 39, 11. So 39, 11. So basically what I said was that this edge should match this edge, and it does. Okay, so that seems to be working. So we now basically need to do all of the rotations and flippings and stuff as well. So if it's flipped, wait. Do this. So if we're flipped around the x-axis, then bx should be 9. So if we're flipped around this axis, we shouldn't check for you guys this edge, we should check this edge. If we're flipped around the y-axis, it should be 9 minus y. So it should go this way instead of this way. So now we have implemented flips. So let's just try to flip around the x-axis. This should give us a different list of inputs or outputs. Quite a bit longer one. We can check 1367. Yeah. Obviously, one is gonna match itself if you flip it. If you flip it over. 1307 matches 1951 when flipped. What did I say? 1307. 1307 matches 1951 when flipped, meaning this edge should equal this edge. And it does, because it's flipped that way. Good. Just get out of that. Right. And if we do both of them, $10.13 matches 29.53. So 10. What did I say? 10.13 matches 29.53. 29.53. If it's flipped this way and this way, meaning that wait. So this edge, yeah, matches this edge upside down, which is if 29.53 is flipped and inverted, so this line here is equal to this line here. Good. Okay. So flips work, it seems. I wonder, can they be flipped and rotated? Or is that like an either or? Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped to a random orientation. Have been rotated and flipped. Rotated and flipped. So let's look at our tile here. So 1951 matches with 2311. 1951. This one has this one next to it. But that is just without flipping or anything. That's boring. 2311 with 3079. 3079 is this one. Is also not flipped. Unless 2311 there is. Triple and a dot. Yeah, okay, so this one is flipped on its head, it seems. To match with this one. I'm just wondering, like, does flipping and rotating change anything? Wait, I have to visualize this for myself. If I rotate that way, that's 180 180 turn is the same as flipping both ways. Is that correct? So if you rotate this 180 degrees, then yeah, that's the same as flipping in both directions. That means that we can save us from flipping both directions. Or rotating 180 degrees. But yeah, so if I'm just gonna do this, I'm not sure if this is right, but if rotation is 90, then if you rotate 90 degrees, I'm going to check this edge. That means I'm now checking the bottom edge, which means that my BX is equal to my BX is equal to Y, or I guess BY if it's flipped. And if rotation is 270, so basically flipped right by one, then I need to check, oh wait, and BY is 9. If it's flipped the other way, then I want to check the top edge. So BX is still BY, but BY is now 0. I guess it's BX, right? Would this also... If rotation is 90 degrees and I'm checking this edge, I want to be checking this edge. But if I had flipped it before I rotated it, I want to read it the other way. Jesus Christ. This is such a pain. So if I rotate it, I want to not go down but over. If I have rotated it the other way, I want to do not down but coming up from the bottom of that. So I want to be going over in both of these cases, which means it should be unchanged. But yeah, bx is by, so in this case it should be 9, in this case it should be 0, but if I have flipped before rotating, rotate 90 degrees, that's that movement. I have a piece of card here that I'm just trying to visualize this, but rotate 90 degrees and a flip should do this, which is the same as 270. So I don't need to do some flips are the same as some rotations, so I don't need to do both flips and rotations, I think. Yeah, so this only accepts 90 or 270. I guess I could call them left and right. And say rotation and rotation is equal to an enum of left or right. Or none, I guess. None left or right. There we go. So let's try to left rotate 1 and see what we get. 2237 should match 1471. Day 20. Why did I close this? 2237. 2237. And oops, not what I want to do. Open a new split. Go over to that one. Should match 1471. 1471. And this should now be rotated to the left for you guys. So this edge should match this edge, and it does. Good. Okay. I think we're on to something. Okay. That's for matching pieces on the left side. Matching pieces on the top side should be pretty much the same, I think. So now A is above B. So we're now going through the X positions. Since A is above us, we want to check the lowest of our Y's. I guess we can do this. And we need our X. So we're going through the bottom of the A piece. And I'm guessing this should be something like this, because we want to check our top, and in the same way, flip X and flip Y should really be the same. I guess rotations are also the same. Yeah, rotated, they just mean the same thing. So I think that makes sense. Oops, daisy. This should be this, and this should be that, at least. Okay. So apparently no piece is matched. That is suspicious. I might have messed up rotations. If bx is equal to by, so when we rotate, we're now checking the top edge. If I rotate left, I want to be checking the left edge, which means that if bx is equal to by, then that's equal to 0 if you haven't done a flip. Oh, and by is just always 9. So this should be 0. This should be bx. It should be 9, and this should be bx. Oh, this of course have to happen before this one. There we go. That gave us some matches. 2341 with 1471. 2341. Oops. 2341 with what did I say? 2341 with 1471. Oops. With 1471. No, I have them on the wrong side. Anyways, this bottom here should be matching the left edge of this one. It does not. The right edge? Okay, it matches the right edge. No, wait, it does. Oh, yeah. it matches the right edge, which isn't correct. So I'm guessing these should have been the same numbers as before. I wondered why those flipped. 2281 with 2237. So you already have 2237. We need 2281. 2281. Oh, 2281. So now the bottom of 2281 should match the left side of this. And it kind of does, but it's flipped, so it's not rotated. It's rotated and flipped. Yeah, shouldn't matter too much if you just do all rotations and all flips at the same time. Should be fine. Okay. This is madness. Let's see if we can do the 9, like the 3x3 thing first. Because this is just test input. Not sure what's going on with my throat. Oh, I might just be dry from all the talking. Anyways, there's an array of 3 things by 3 things, and those things are ints. We also can't place a tile more than once, so we have left is a set of uint 16. Right. Well, true. F. No. Oh, just this part is hard. Fuck me. Creating permutations in a reasonable way. So I guess we don't need this. So we have our 9 tiles. We have our 9 tiles, and we should create every combination of those 9 tiles and go through them and check every rotation and flip of all of them with early termination. That's basically what we're doing. So my brain is just not working today. This sounds good. For a collection C containing n different elements, you find a systematic method for choosing at each step a pair of elements to switch in order to produce every possible permutation of these elements exactly once. Right, we have an array of any, and it goes generate permutation from kth unaltered. Right. Non-recursively. Isn't there a yeah, we have permutations in calculates the next lexicographic permutation directly modifying x. Sorry. The result is whether a permutation happened. Otherwise, we have reached the last ordered permutation. If you start with unsorted, not give you all, but stop at last. Right. So we need to sort them and run that. Okay. So algorithm. Is that really the only? Isn't there something like this in Secutils? I mean, this could have been an iterator. I mean, this could probably be written as an iterator. Let's see. So we first need to get keys to sack tiles. Oops. Tiles dot keys to sec and then while or keys dot sort while keys dot next permutation is not equal to true. Yeah. Okay. Yep. Now we have them as permutations, lexicographical permutations, which is not really what we want, is it? Because we want to be going sort of in and out. I guess if you used memoization, it could work. No, but we still need early termination to have any chance of this being fast enough. Yeah, I think we need to do this recursively. So proc choose tile, I guess. Position is an int. And then choose a tile on 0. But this needs a left. Do we have ordered sets? Do we have something called an ordered set? This is all just a big mess at the moment. To ordered set to sec tiles dot keys. So those are the ones that are left to select from. Why do I have them in a set? I had an ID for that. Sure, whatever. Okay, so for key in left, tiles, pause, mod, tiles dot height, length, pause div tiles dot length, and this should of course be this thing. If pause is not equal 0, if pause is 0, so if we haven't gotten any tiles yet, then for key in left, set this to key and choose tile 1. If pause div tiles dot high, is that right? No, high would be 0, 1, 2 are the indexes, so 2 would be high. I need length. Yeah. Length equals 0. I think that takes precedence, so let's do that. So if we're at the first row, we only need to compare to left. Then tiles, whoops, four key and left. Oh, and wait, does that return a set? No, it just takes one. Left dot exclude key left. Not sure if that works, to be honest. I don't think this likes that we modify this. New left equals left, and then new left dot exclude. That should be better. It wasn't finished here. So if we're on the first line, we only need to compare to the left of us. So we only need to call match piece left. So if tiles 0, because we know we're at on the first one, we know that's not going to be higher than 1, so that should be fine. Dot match tile left, match piece left, left the key, and for now just do non false. If it matches, do this. Choose the next one. I'm gonna make that a template. Add and next. Pause +1. Right. Four key in length. Yep. So also do add and next. It should be like add and try next, I guess. If pause mod tiles dot length is equal to 0, so if we're on the first if we're in the first column, not the first row, we do this, but we do this, and we only need to check those at one above us. Otherwise, these should just be all elifs. Otherwise, I need to check both directions. So I need to check pause div tiles dot length pause mod tiles dot length. Ooh, no, other way around. What is wrong here now? This should have this and that. Int index rotation. It's complaining because this is an int, not an index. No, not really. Oh. It's complaining that it's a false, not a false, false. The error messages in MLSP and suggest could be a bit better at sort of pointing out where they are. Oh, not tiles.key, but I guess piece is .keys. Yeah. Right. This checks without any rotations and such. I guess I should write a proc here to, like, with an override or with a whatchamacallit, which basically says for route and rotations or rotation, and for can I do this? I mean, it would be cool if I could, but I'm not sure if I can. Match piece left, A, B, rot, flip X, and flip Y. Oh, bollocks. I can't do that. Because it might match multiple ways, but only one will match a further way. Okay. For rots in rotation, let me just check if I can do that first. I can. I'm gonna write a template with options. Just a body of untyped. Could do this with an iterator as well, but we're not gonna. For rot and rotation body, and this should be injected. And now we can do that. Oh, if we do with options. Yeah, with options. I mean, this might be so horribly slow that there's just no point in doing any of this, but who knows? We might get lucky. So now we need to do for flip X, inject in bool. I don't think I can do that. No. So I'm just gonna say true, false. I can actually do this. Yeah. Because bools are, I guess, technically an ordinal type. Flip X, flip Y. Flip X, flip Y. Flip X, flip Y. Oops. Flip Y. And flip X, flip Y. Right. If position is equal to 9, or I guess tiles dot length times tiles 0 dot length, now we just basically want to break out of everything. Let's just echo out tiles and quit. It's ugly. It's probably a mistake, but hopefully it will work. What is the issue here? We have called choose tile twice from add and try, or maybe only once, for 93. Choose tile 0. We try to look up the key in match piece left, called from here, which obviously won't work. Somehow we've messed this up. Line 93. Tile 0 position. This should have added to 0, 0, right? Echo out tiles here. Might just be that my math is wonky. It is. Oh yeah, no, that's right. Yeah, so for 0, we don't have anything. We just input this and we go on to the next step. And in the next step, it comes down into here and it checks the position at, oh, that should of course be that. Yeah, all of this is just wrong. Like that. done something wrong here. If position divided by tail, so if it's too low, then it should take plus minus 1 as the x, but always at 0 y. If we're in the first column, no, but it's yx, right? It's yx. Yeah, that's right, but this is wrong. So this should be this, and this is flipped, I think. Like x, y. It's weird when you have them in a table like this. Key not found. Key error from line 104 down here. So basically what happened here was that we apparently found a configuration that worked for the 3 first tiles. Then it tries to add this one, which should only look at this one. And that led to 0 because this one isn't updated at all. Oh wait, what? How did it get down there? 104. Oh right, we're trying to place the next one. Right. So the one to the left should have a -1 over there. And the one we check on top should have a -1 over there. It seems to have gotten stuck in a loop. It's trying to put the next piece in. It shouldn't have taken it this long to go through that short list of things. Oh wait, it was... Yeah, I guess it was going like... Wait, what actually happened there? I guess it's just trying all the permutations. But no, there shouldn't be that many keys in left. mean, there aren't this many keys. So this list has to have just repetition. Wait, actually it doesn't seem to have. Wait, is this just that slow? Oh wait, we're calling this an R input, not the test input. I mean, that doesn't bode well for what we want to do, but got further. Yeah, so it seems to have gone like back and changed this one. Right, yeah, it doesn't null them out again. So it's that one, it's that one, it's that one, it's this one. And then it apparently managed to place that one. And then it's trying to put this one here. But that chooses a bad tile. And line 105, 107. Oh, this is... I forgot to change these from earlier. The XY issues we were having earlier. Well, I can guarantee you that this isn't right. What? What the hell happened there? Quit, but did we actually get, like, did it think that we're there? No. I just quit for some other random reason. Like if I remove these echo statements, now it should run and just only output the tiles when it's done. So it just somehow quits. I guess that means it didn't find any. If position is 0, go through all the keys and that's left. Add that key to position 0. Remove that from the list of things you can use and try to pick the next one. The next one looks only to the left because it's here. Checks all the different ones. If any of them match, go one step further and remove the key. Wait, what is... this mess? Oh, because it's the first line, so it's always going to be like the, yeah. Oh shit, yeah. Uh, the first one must be rotated and flipped and shit. Which this code just doesn't support because it only applies the operations to the second one. Damn it. Okay. I can actually flip them? I hate this. So basically this thing, I need to create all of the rotate and flip and whatnots. And since all of this is done by indexes, I need to put them into my table of pieces. So I need to create the pieces in flipped and rotated and whatever mode and put them in, which is exactly what I didn't want to do. I could write a special case because there are only ever two positions that will test against the zeros, 0, 0, 1. So I could have like if position is 1. Don't do this, do a fuckaroni version of it. And this is still just way too slow as well. You know? Like, okay, wait, let's compile this. So this only checks like a small subset. And it still takes half a second on the small data set with a subset of what we need to do. There is... Yeah, there is this memo package. Not updated a whole lot. I'm gonna try something. we are going to memoized. This is just basically black magic. I'm not sure if this works. 414. That took longer. Great optimization. Basically what memoization means is instead of running, like it creates a table of results basically. So if we have compared two tiles with the same AB, so if we have compiled, or if we have compared the same AB with the same rotation and flip stuff before, then we don't need to do it again. It's basically what the memoization thing means. But I guess in this case it's not actually that much faster. Yeah, because it's not recursive, so it won't give us much of a speed up. I need to go to the bathroom, and I'll be back in a little bit, and we can see about what we're gonna do here. I guess, I mean, we could cheat and like change it, like create a copy of it in the table just with a random high ID. So create a new one that doesn't exist, input it, like make it a copy which is rotated and flipped in a specific way, and input it as the first element and hope no one notices. But still, I think this is already too slow. I mean, we saw before, like, what the result of this is basically picking 5. Oh, not even. It's basically trying like up to 5 out of 9. And it grows exponentially. And we have a, what, 12 by 12 grid or something? So this ain't gonna be fast enough. It annoys me that part 1 of this is so hard. Like, part 1 should just be like comparing these, like without rotations and stuff. That would have made part 1 at least overcomeable. But yeah, I think we're missing. Yeah, I think we're missing something. There has to be some kind of clever logic here. I mean, I guess we could go through, right? And like flip and rotate and do all of that on all of our tiles and find the ones that go together. And then sort of like place one tile, then just pick from the tiles that we know it can fit next to, and carry on with that until we have it. But yeah, I guess we do need we do need to be able to flip this, not only this, for that to work as well. Maybe I should like break this out and say like this is a piece, right? And then take in two pieces and then place pieces on the board instead of ints. Yeah, that would work. The logic in this would be hairier, though. I mean, it won't be much. It's basically just a copy of this for y as well. Okay, we can do that. But yeah, as I said, I'm gonna go to the bathroom real quick first. So yeah, I'll be back in a second. And I'm back. I also brought some figs and dates and stuff because I noticed that my blood sugar is kind of getting low. Right. It was this horrible mess. Yeah. What should we call this? Because I've already used piece. Let's call it a tile. It's an object. It has a piece. It's an index. Sure. Tile. That's basically just replaces this bit. And this is ugly. It's very ugly. Oh wait, I went too far. There. And then this is AY and this is AX. And this should be A, and this should be B, B, and B, and B. So of course this. It wasn't called tile, it was called piece. There. So now this one, I mean, it's ugly as sin, but this one will now do both A and B with rotations and flips. And compare them. Basically need to do the exact same thing for this. I'm actually gonna do this before I copy it. Let's just do a search and replace instead of what I was doing. That should work. These should of course now be what do I call them? Tile. These should of course not be tiles. And this needs to have the same, actually the exact same thing. There. Okay. Now in here, this now needs to hold, what do I call it? A tile. This now needs to hold a tile. This obviously can't take a key. But that is in add and try next. That is always called from within with options. I should be able to do tile with piece key and then rotation rot and flip x. Flip x is flip x. Damn, that's a hard word to write. And flip y is flip y. New left. Yeah, that should be the same. So, like that. And then this should now just match. So in here, let's actually not, let's not write out these. Let's generate this tile. Right, tile. And inject this instead. And we're going to do, whoops, that was not what I wanted to do. I want to do this there. Let's rename this to with tile. This didn't seem to work. And then say with tile. This, of course, now can just be tile, not tire, tile. And this thing can also be tile. And this has to be with tile, with tile. This is also tile, with tile. And compare this with this tile and this with this tile. We actually had an issue or an error in our code before. I just noticed that if we checked a piece, if it matched with some sort of rotation, then we inserted it into our array here. But that was without any rotation. So the next one would check against a rotation that wouldn't fit there. So this should actually be more correct as well. Or it should be correct. Oh, let's not run it with release mode. But I was just about to say, it's also going to take way longer. But it seems to just stop for some reason. What happened? It only did like 2 pieces, and then it stopped. Well, so basically when it stops without having found anything, that means that it just didn't find any correct thing. Also note that I added this with tile thing here. So that we will check all the tiles. Or all the rotations and flips and whatnot. That is weird. I mean, it might be that this logic is just wrong. Although I don't quite see how, because it's just a copy of the same logic for this direction, which we have already checked. So I'm not really sure what is wrong here. And just some Christmas cookies. Can you hear horrible chewing? It's just watching the volume meter. It seemed fine. Honestly, I'm a bit lost on this one. And we have been going now for 2 hours. And we're not even done with part 1. I feel like I've just gotten into somewhere where, like, I've done something wrong with my logic somewhere, and this isn't gonna be salvageable no matter what. I think it's too slow as well. So there's probably some more logical way of doing this. I mean, if we look at our input here, there are just so many more tiles than these 9 tiles that we are already struggling with. Are there anybody even still watching this? It seems to just try every combination of the two first positions. Or I guess the three first, since you start counting as 0. Without finding anything, which is a bit peculiar. Oh, wait. Shit. I just copied the logic for X, so I'm comparing the wrong side. Right? And this should be 9. Same for this. Because we want to compare the right and the left to the... Yeah. This seems to be getting further, at least. Seems to be going for all the variations of 6. Oh, now we're up to 8, 7. Come on. Come on, you bastard. I mean, it probably has to go all the way back down to 1 again at some point. I just want to see it working once for the test set. This is where memoization probably would give us a speed benefit. Because now it's bound to do the same comparison a couple of times. But I'm not sure if... Like, we're just comparing booleans in an array, which would be pretty fast. So I'm not sure if it actually gives us any meaningful speed up. I have to get some dinner at some point. 6s, so we drop down a bit. This is gonna take forever. Oh, that 12 by 12 grid with a bunch of extra tiles. I mean, this is on a 9 by 9 with 9 tiles. The other one has 144 tiles. It's gonna take freaking ever. I mean, it doesn't help that we're now outputting, like writing to standard output all the time. That doesn't exactly speed things up. And we didn't compile in release mode in case we had an error. Well, well, well. I mean, this is just a practice run to check if our implementation makes sense. It should be running in milliseconds, not in minutes. Okay, so what kind of optimizations can we do? Memoization, which, as we saw, may or may not give a speed up. We could do what I was talking about and like setting up all the pairs. So basically generating all the different kinds and creating like the pairs that match a tile. So you can place one tile and then we already know which tiles it can go with. And then we can try those and we know what tiles they go with. So we can try those, etc., etc. I mean, that would mean pre-computing a pretty big table of all of the like matchings. But that could speed things up. Is there anything else we can do? Is there anything we've missed? I mean, as I mentioned, the middle part doesn't really do anything. Right? The middle part is just like useless to us. So we could unpack these into a string. Rotations would then be just jumping to a different position in the string. Flipping would mean reading the opposite direction. Wait, no. Yeah, flipping an X would mean reading in the opposite direction. Flipping an Y would mean an index change and reading in the other direction. Well, that doesn't really give us anything. It saves it a bit, us a bit of memory, but it doesn't really give us any meaningful thing. We could, of course, have these as well, maybe that would work. Save these. Store these and the flipped version. Right? So take this and take the flipped version of this. Store those in a table pointing to the ID of this tile. Take this and the flipped version. Store that in an index. Same for this. Same for this. A rotation basically just means reading another one. Right? So rotations is just, instead of reading this, we read this. Or this, which is the flip of this. So if we store all of these 10 chunks with an ID, we're pointing to our ID, and then maybe we have another table from IDs to these flips, or maybe just one of them. Then we can go through and compare all the other flips, have the key, but we wouldn't know, after we've placed one, we wouldn't know the next one. So for example, in this case, if we had just placed this one matches this one, we wouldn't have this one. So you would need to store them in pairs. So top one and bottom one, and flipped, and right one and left one, and flipped, and of course flip the other way. And rotations are still just this one and this one. Yeah, so if we store pairs, of lines with their flips mapped to their ID, does that give us a speed up? We could then compare. It doesn't really speed us up any. It doesn't allow us to remove any path that we would need to take. Basically now, if we have a deep, so if this one worked in either flipped way, for example, and we placed this one, and we got all the way to almost the last one and figured out, there's no final piece. We went back and we tried the flip version of this, and this piece would still fit. We might have subtrees that we can just ignore. That would be tricky. This is taking forever. I think the only optimization I can see that being like semi easy to implement and could give us a reasonable speed up is the table of like what can fit next to me. So we would have, but that means it would take a bunch of memory. Or maybe not that much. How many? So with our rotate and flip things, how many unique combinations do we have? We have 2 for rotation, 2 for flip X, and 2 for flip Y. I guess we have 3 for rotation. So for each tile, we have 12 options. I guess it would be nice if this sort of elaborated a bit more about what kind of rotation and flipping was allowed. But basically, one of our tiles can have 12 different orientations. That means that with our sorry, I'm gonna make the size here bigger. That means that with our 144 different tiles in 12 different orientations, that is only 1,728 unique. I don't think they are all unique even, but unique things. So if we stored the subset of those that could match with this one, and then did that kind of looping, yeah. Another issue with this is I have no idea how long this is gonna take. Like, this might be the final time it's in the 5s and 6s. 7, 8s. Come on. There's one option left. One thing you need to place. A single little tile that needs placement. Come on, you piece of shit. I kind of don't want to abort this now because it's been running for so long already. Let's have that running on the side, and we'll oops. Let's see here. For our part 1. Just edit anyways. Great. It finished. And it didn't even get a good result. So we still have an error. Well, shit. Fuck this. I don't even know if I want to implement what I was talking about. What happened with these two just being brutally hard? I mean, this was a breeze. That was a bit tricky, but... What's the problem with this? Well, yeah, this was just like... It didn't work for me, for whatever reason. And I couldn't really figure out why. And then this one is just, fuck you. Reading this and this. Calculating the flips. I mean, flips and rotates are just the same thing, pretty much. So if you add these pairs and the flipped pair, and then compare every left, right, The only difference is what side will then be on the next thing. Hmm. Would be nope. I give up. At least for now. This isn't working. So I would have to implement something completely different to get that working. And I'm not quite sure what, because none of the things I'm thinking about will be massively better. I mean, one speed up, I was thinking about turn these into bit masks, like just 10-bit int or 16-bit int, so we could just do equals to compare them. That is one way. The other was the one I was talking about, generate the set of pieces that can be to the right of this one and below this one for all rotations and flips of this piece. And then go through all of them and only check the ones that we know can go there, which is kind of a memoization thing. But the fact that this didn't complete with anything, tells me that even my basic logic is just wrong. Which means that we have quite a while to go to fix this, to get it working. And I'm not sure if we want to go there. So yeah, bit of a disappointment today. Still a bit annoyed that we didn't get the second star on 19. I might look into that as well in 20. And curious to see what the next ones will be. If I stream tomorrow, it's going to be later in the day than yesterday. Or not yesterday, than what I have been doing. But yeah, that's all I have for you today, really. I might revisit these. If I solve them off camera, I will show off my solution. But to be honest, I'm not sure if I can be arsed to. Okay, anyways,